Okay, the following is a video about 12.3 notes. We're going to continue our learning of surface areas and lateral areas, but we're going to be doing these with pyramids and with cones. So it's a little bit different, but the first thing I want to talk about are what we have here as far as what we label these things and what we'll need. The two main things that I want to point out here is that we have the height of the actual pyramid, and we call that the altitude, okay? And then we have the height of one of the faces of our pyramid. We call that the slant height, and we're going to need the slant height when we talk about lateral and surface area, okay? And we have the same thing over here with the cone. We have the axis, or the altitude of our cone. That's the height of the cone. But then we have the length from this point to this point, which we call the slant height. Okay, now what I want you guys to see here is that what we end up getting here is we end up getting a right triangle that's created on the inside. Same thing here. And so we will be using, sometimes we won't be given the slant height, we'll have to find it, and we'll have to use Pythagorean theorem to do that. Okay, so let's kind of talk about the formulas for lateral area and surface area of the pyramid. My lateral area, L, is equal to 1/2 times the perimeter of the base times the slant height, L. Okay, so I'm going to write out that P is equal to the perimeter of the base. Okay, and that L is equal to our slant height. Okay. And then if I wanted to find my surface area, then I would take the lateral area, which we've calculated here, plus the area of the base, okay, B. So B is the area of the base, okay? So those are our formulas, okay? As long as we can understand those and find those values, we just plug it in and evaluate, okay? Let's take a look at the surface area and lateral area of a cone. The lateral area is simply just going to be pi times our radius of the base, which is this length here, times the slant height, L. Okay? And so then our surface area is equal to our lateral area plus the area of the base. Okay? When I use this big B, it means area of the base. Okay, but we can kind of come in here and we can say, all right, well, this is really just the lateral area is pi r times our slant height plus the area of the base. Our base is a circle, so that's just pi r squared. Okay, so let's take a look and let's apply that to problem number 1. And the nice thing is, you know, let me just write this out. L is equal to 1/2 times the perimeter of the base times my slant height. I want to identify here that this length here is our slant height, L. Okay, and what we have here is we have regular pyramids, so I know that the lengths of my base, those are all the same, those are all 4 centimeters, okay? So if I wanted to find my lateral area, I would simply just take 1/2, and because I have 4 sides of my base that are 4 centimeters, I'm going to take 4 times 4 centimeters for my perimeter of the base. And then I'm going to multiply that by my slant height, which is 7. Okay, so I'm going to come in here and take 1/2 times 8 times 7, and that's going to give me, 1/2 times 16. 4 times 4 is 16. We'll get 8 after we divide it by 2. So this is 16, so 1/2 times 16 is just 8 times 7. And that's going to end up giving me 56 centimeters squared. Okay, and that's my lateral area. Now for my surface area, I want to use my lateral area. Surface area is L plus the lateral area plus the area of one of the bases, because I just have one of them. And so my surface area is equal to 56. And then because this is a 4x4 square, I'm going to add this. I'm going to add 4 times 4. Okay, and so I end up getting 56 plus 16, which ends up giving me 72 centimeters squared. Okay, so that's what I got for that. All right, so let's take a look at number 2. Now, number two, this is one of those where we are given the altitude. We are not given the slant height L. Okay, so I'm going to call this L here. Now, what I know is that I have a regular pyramid, so I know that all of these segments are congruent. But what I do know is that I have the height of this right triangle inside of my pyramid to be 12, and I know that this length here is 14 feet. Now, what I have here is when I have the height of this is actually, this length is half of 14, so this length here is 7 feet. Okay, so it takes a little bit of intuition to kind of know that. But then I'm going to evaluate this. I'm going to use Pythagorean theorem. And we've done this so many times that I'm just going to take 12 squared plus 7 squared. And that's going to end up giving me the square root of 193. And this is what I'm going to use for my slant height L. Okay, I'm going to operate with that number. Okay, so if I come in here and try and find my lateral area, I'm going to do 1/2 times the perimeter of the base times my slant height. So my lateral area is 1/2 times the perimeter of the base. Now I've got, each side is 14 feet, so I'm going to take 4 times 14 feet, okay, and then I'm going to multiply that by the square root of 193. Okay, and what I'm going to end up doing here, I'm going to take half of 4, which is 2, so I get 2 times 14 times the square root of 193. And when I do that, I end up getting 28 times the square root of 193. All right, so since I have this, I'm going to use this to operate with. Okay, we can approximate this and we can get an actual value. We'll round to the nearest tenth. And when we do that, if we plug this into our calculator and we round to the nearest tenth, we end up getting 389 feet squared. Okay, but when I'm finding my surface area, I want to use this to evaluate to help with that. So my surface area here is the lateral area plus the area of the base. Now I already have my lateral area, so my surface area is 28 times the square root of 193 plus the area of one of the bases, which is just 14 times 14. Okay, it's a square, so 14 squared. And when we plug that into our calculator, we're going to end up getting 585 feet squared. Okay, so we got to round those. All right. Now, let's go ahead and take a look at the cones. Problems 5 and 6. Kind of made a mistake on the notes. It should be 3 and 4, but it's 5 and 6. Now, when I have this value here, okay, because the 14 meters is right next to this length, if the 14 meters was right next to my altitude, then I would know that that length is 14, but this is my slant height L. Okay, and I know that just because it's on the outside. All right, and you'll see that if your measurement's on the inside, that'll be your altitude, but this is really my slant height. So if I wanted to find my lateral area, I know that that's pi times my radius times my slant height. So our value here is pi times 5 times our slant height, which is 14. Okay, and so when we plug that into the calculator and round to one decimal place, we get 219.9 meters squared. All right, that's my lateral area. Now my surface area, remember, is pi times r times our slant height plus pi times radius squared. So let's just plug all that in. So pi times 5 times 14 plus pi times 5 squared. And if I put that all in the calculator, I'm going to get 289.5 meters squared. Okay? And so that's what I get from my surface area. Now the next one, now notice here that you're given this length here of 25. Okay, this is my altitude. This is not my slant height. So my slant height L is this value here. Now what's formed here is a right triangle. So I can use Pythagorean theorem to find that length. And I just take 10 squared plus 25 squared. And when I evaluate that, I get the square root of 725. Okay, I'm going to use that as my slant height L. Okay, so sometimes you're given that, sometimes you're not. So I'm going to come in here and find my lateral area, which is pi times our radius times my slant height. And now my radius is 10. Okay, that's my radius, so I've got pi times 10 times the square root of 725. Now when I plug all this in, okay, it's going to give me 845.9 feet squared. Okay, And that's some calculator work. Okay, you just got to plug those in. Now maybe you're not plugging it in correctly. Keep trying to plug these values in until you get the right thing at 145.9 feet squared. Okay, now for our surface area, I've got my lateral area plus the area of one of our bases, which is just pi r squared. So surface area is going to be pi times 10 times the square root of 725, and then plus the area of our base, which is just pi times radius squared, which is pi times 10 squared. All right, and so that is going to end up giving us 1,160.1 feet squared, and that's our surface area. So guys, if you can identify what these things are, then we can actually calculate the area of the surface. Now it seems a little weird because we're finding the area, the surface area of a cone, but we can actually do that. So please get started on the notes or on the homework. I hope you enjoyed this, and we'll see you soon. Thank you.